All right, let's go ahead and solve this guy right here. 3 tangent cubed of x equals tangent of x. And I just added on this, we're just going to do it within 0 and 2 pi. Okay, and I'm just going to try to make a distinct difference between doing it within an interval and doing it when it's not within the interval, so that it's very clear the difference between the two answers. Okay. All right, so if we're going to factor, let's write everything on one side. So I'm going to go to move the tangent and put this on the left-hand side. So I'll have 3 tangent cubed of x minus tangent of x equals 0. Now we have a common factor of tangent of x. So I'll take out a tangent x, and I'll get 3 tangent squared of x minus 1 equals 0. So now I have 2 factors equal 0. That means I can set each factor equal to 0. So I have my first one, tangent of x equals 0. And I have my other product right here in the parentheses. So 3 tangent squared of x minus 1 equals 0. Okay, we'll start with this guy. Tangent of what equals 0? So we're finding all the x values that are within 0 to 2 pi. Well, there are 2 places on the coordinate plane or on the unit circle where when you do y over x you get 0, and that's when x is 0 and where x is pi. Okay. If I'm at 1, 0, that's y divided by x is 0, and if we're right here at negative 1, 0, y divided by x is 0. So that's why one of them is 0 and one of them is pi. Okay. Now over here, let's just go ahead and solve for tangents. Tangent squared of x equals 1/3. But then I'm going to take the square root of both sides, and I emphasize again, I'm going to do that, which means we need to put the plus or minus radical 1 over 3, which is the same thing as plus or minus 1 over radical 3. Or if we rationalize that, you could do plus or minus radical 3 over 3. So we need to find all the places on the unit circle where we have either positive radical 3 over 3 or minus radical 3 over 3. Well, that occurs in each of the 4 quadrants. So we're going to have 4 more answers here. And I'll just write those 4 out right here. See, the first one, it is pi over 6, and then we have 5 pi over 6. Then we have a 7 pi over 6 and 11 pi over 6. And you can verify all these by just looking on the unit circle and seeing when you do y divided by x, you can get 1 over radical 3, and it's either plus or minus. So we had 1, 2, 3, 4, 5, 6. So we have 6 answers. Okay, 2 answers here and 6 answers here. And notice that when we're supposed to find the tangent of something, we just look and see, okay, we have to find anywhere within the interval from 0 to 2 pi, and we just go around the inner circle, and every time we find one, then we're just going to write down that radian. Now, what I want to do is this now. What if this was not there? Meaning if the 0 to 2 pi was not there. Okay, and I'm just going to kind of write in this space. How would our answer differ? And I think it's important that I just make this a distinction here so that you're not confusing, because the answers, it's not only the whole, when you add pi n where n's in the integer. Yeah, that's part of is different, but another thing that's different that I need to point out is if it doesn't tell us specifically what interval to look at, meaning like, it did say from 0 to 2 pi. When it says, okay, just find the solutions just like this, it didn't say anything. So that means it assumes that they want all the solutions. Then that means, you might want to make a note of this, then that means that when we are looking, for example, like right here, okay, like when we have tangent of x equals 0, we are only looking for the x values, okay, listen now, we're only looking at the x values within the period of tangents. Okay. See here, we didn't care what the period was of tangent because it said that we were supposed to look from 0 to 2 pi, right? So I think it was like this actually with the bracket right there. But see, that's the difference right there, is that now when we're looking for this x right here, we actually need to only look between negative pi over 2 and pi over 2, because isn't that the domain of tangent? So in that case, it would be x equals 0. Okay. The period of tangent is pi over 2, right? Isn't that what it's from? Actually, it's from negative pi over 2 to pi over 2. So we have to look within that and say, okay, when is it? Those are the only x values where tangent can be 0 when we're looking in this domain right here. So then you have to put plus pi n, where n is within the integers. Okay, and then even if we take this down here, when we said the tangent of what equals plus or minus 1 over radical 3, okay, we only are looking for the ones between negative pi over 2, okay, negative pi over 2 and pi over 2. And if we look at our unit circle here, it's only going to be the 11 pi over 6 and pi over 6. And this is what I mean. So you would put x equals pi over 6 plus pi n, where n is within the integers. And see, look, if I were to add pi right now, let's just put a 1 right here. If I add pi plus pi over 6 is 7 pi over 6. Oh, look, that's that guy right there. You see? So we are going to still reach these values, but when you are finding the values of tangent, cosine, whatever it is, and they don't give us a restriction, then you need to find those values within the domain of that function, or basically it's within the range. I'm sorry, within the period, okay? And since a period is within, from negative pi over 2 to pi over 2, that's what you should be looking at there. And then lastly, the other answer then would be 11 pi over 6 plus pi n, where n is within the integers. Okay, so just notice the difference between the two. So I'm just going to highlight. So these are my answers for when we had those restrictions. And now these are my answers when there were no restrictions. They have some similarities, but nevertheless, they are not the same. Hopefully that's clear, a little bit clearer. If it's not, then you can please ask in class, and I can make that distinction again by giving more examples so you can see the way that you need to respond when they do or when they don't give you any restrictions.